Numerical integration using MATLAB's trapezoidal method. So calculus says that the integral of some function of x between limits a and b can be evaluated using the series for ever increasing values of n, where the delta x is based on the difference between the limits of integration divided by the number of steps we're taking. And when you break down this series, each term in the series represents kind of the average of the function between two successive points in x times the span of x that we observe. As you probably remember from calculus class, this can be rather tough to analytically find. There's lots of methods. Mathematicians have done a good job, but sometimes we run across things that are just frankly impossible to integrate by hand or utterly impractical to do so. So let's break things down into numerical methods. Let's have x be an array of numbers from x1 to xn, and f of x will also be an array of numbers from f1 to fn. Then we can approximate the integral of fx dx as an array of numbers as well. Okay. Based on breaking down that series presented on the previous slide into a finite number of steps, because we have finitely long arrays. Graphically, this would look something like this. We have some curve f of x, and we've got 3 points identified on it. The series breaks down into a series of rectangles, and those rectangles have the height of halfway between, essentially the average between two successive points in f, and a width of the span between two successive points in x. Okay. This rectangle can also be approximated as a trapezoid, and that is where we get the name trapezoid method of integration. Now, as we take smaller and smaller steps in x, we get closer and closer to the analytical solution. Ultimately, as we take the limit as delta x goes to 0, we're taking differential steps in the x direction, and the trapezoidal method becomes exact. Most of the time, we don't need an exact solution. We just got to be close enough that any error is negligible. And what negligible means depends on your application. Let's put this in code. Given arrays of x and f of x in MATLAB, here I've got x is 1 to 5, f of x is just x squared, but you can have any arbitrary collections of numbers for x and f of x. MATLAB provides what's called the trap-z function, trapezoidal function, to return the total area under the f of x curve across a spacing in x. So you can see the integral of from 1 to 5 of x squared should come out to 42. A quick check would provide you that same numerical result. Now, many times we're content with that total area under the curve, the total integral across x, but sometimes we want the integral between each point in x up to that point. So for example, starting from x1, the integral from x1 to x2, x1 to x3, x1 to x4, and so on until we run out of stuff in the array. And that is where MATLAB provides the cumulative trapezoidal function. You can see the function returns an array with 5 values in it, corresponding to the integral from x1 up until that corresponding value in x. So the integral from x1 to x1 is 0. The integral from x1 to x2 is 2.5. From x1 to x5 is 42, just like we found previously. And that's how we integrate numerically using MATLAB.